Hi, Algebra. Just a short video on the concept of showing your work. And, you know, as a science teacher, and we have a saying that goes that scientists are inherently efficient, and sometimes in efficiency, we, can cut some steps. Like if I'm going to do a math problem, it's 3 plus 5 plus 2. I could say, oh, gee, that's 10. Because, now, I can kind of do this in my head. 3 plus 5 is 8. 8 plus 2 is 10. Or I see 3 and 2 is 5 plus 5 is 10. However I do it, that's a pretty simple problem. And I'm like, I don't need to show my work. We could, however, do it this way. And then we say that this becomes 8. Hit my finger on the home button there. 8 plus 2, and then equals 10. So, we essentially start with our original function, or original expression. It's kind of like, really, this is an expression because it's not anything, plugging in a variable. It's not an equation because we're looking for the arithmetic result of this. And so really we would call this an expression. And then we do a calculation, and then we calculate again. So we state the problem, and then we have two different calculation steps that complete this particular calculation. And we know that we could apply the commutative property. We could do this in the order because it's an operation of addition, but we don't really apply that. If for some reason I wanted to rearrange it, let's say that I recognize that 2 and 3 make 5, so I'm going to do this. And I can do that because, excuse me, associative. The commutative principle lets me do that, and then I have 5 plus 5, 10. So then I have a calculation and another calculation. So each individual step, if you are thoroughly documenting your work, is going to be a specific operation that we pull out of our overall algebra and arithmetic toolbox. And the value in doing this, and like for this one, you're going, oh my goodness, that looks like it's way too much work for 3 plus 5 plus 2. And I agree, it is. But math problems don't really get any easier than that. In fact, they get harder. Not that the math is all that much harder, but there just becomes more steps, potentially a lot more steps. And by writing out every step, you're going to help make sure that you do it correctly. So many times I've had students that, I'll ask them, well, why did you divide 12 by 2 in that situation? I don't know. Well, you need to know. You need to have confidence in each step that you put down on paper so that you know why you're doing it. And if you can give a good reason for it and all the logic flows from beginning to end, then chances are you're going to end up with the right answer at the end as well. And even if you don't, when you or I or somebody goes back and tries to retrace your steps and figure out where you went wrong, you'll be able to do that, or they'll be able to do that. It's a fundamental part of the scientific method of document your steps, follow your steps, document your procedure, don't skip steps. These are all things that we learn in science class, and it's natural to think of it because if you don't follow steps correctly in a chemistry class, the next thing you know, we're calling the fire department, and things are on fire and bad things happen. So we don't want that. We don't want that to happen with your math. We don't want your math to blow up on us. So if we take a problem like we did kind of in the functions pop quiz, so let's say f of x equals 3 times x plus 1 and plus 2x. And then the question says, what is f of -2? So that's what you're asked. So the first thing that you're going to want to do is, if it's not already done, and in the case of our quiz, it was kind of written out, but you want to write out your expression or your function. So we've done that here. So this is the particular function that we want to do. And then we were told to solve for f of -2. And so I'm going to do a mathematical operation here. I'm going to say 3, and I am going to replace x with the -2. And when you replace something in mathematics, that is called a substitution. So I'm pulling from my toolbox over here of things that I can do to solve this function. So I substitute in -2 plus 1 plus 2 times -2. So I have carried out a substitution. I have replaced all instances of x with the -2. So then we have a situation here where we're going to apply PEMDAS. And again, I could write f of -2 here again. I probably should. However, in math, often if one thing repeats entirely from one line to the next, we just kind of leave it blank, and we're going to make the assumption that, use ditto marks like you would in English notes or something, but we can just kind of leave it blank and then carry on with the equal side down, because we're not changing anything on the left side of the equal sign. So I'm going to take 3, and now this becomes -1 plus 2 times -2. And so there I did a step of addition. Or I could just say I did a calculation, because addition is a form of a calculation. And then I'm going to do -3. I do a step of multiplication. Oop, I'm hitting myself. Do another step of multiplication. And I know it feels like, well, gee, can I do both of these two at the same time? Maybe as you get more efficient with this, you can start to do that. But again, our problem is we want to be very methodical in each step so that we don't accidentally skip steps. And the more you say, well, can't I be more efficient by doing this, the greater the risk you get of that shortcutting causing you some problems and you miss something. And then, so we do this. This is an addition. And then that ends up being our final answer, circle our final answer. So in this process, there's a very clear path, a very direct flow of information from start to finish of the function that we began with and the answer that we ended up with. This is what's meant by showing your work, a logical flow from beginning to end. It's like a recipe. When you're baking something, you want to know, what do I do first? What do I do second? And, you're trying to make cookies and you forget a step in the middle, generally they don't turn out very well. So it's kind of like the same as a math problem. If you skip a step in the middle, then you're not going to get the right number. And this whole process helps to make sure that doesn't happen.